So the GitHub Actions workflow failed at this step to log into Azure with the user-assigned identity information that's stored in GitHub Secrets for this repository. That was all generated by Azure App Service in Deployment Center. It can be a bit overwhelming when something goes wrong like this, especially when this is a new technology for you. But like I teach in my course on debugging, the clues are usually in the error messages. It says here that no matching federated identity record found for presented assertion subject, repo, Morse code, deployment app, environment, dev. Okay, so this is some sort of token that's getting sent by GitHub to log into Azure, but it's not being found in Azure. So let's keep this in mind for debugging the issue. But before we do that, let's go back and take a look at the workflow YAML file. And I'll explain the actions here that you saw taking place during the workflow run. I'll zoom this in a bit in the browser using Control and the plus key. Let's walk through what's happening here in the generated workflow file. The first section defines when the workflow will get triggered. In other words, what causes it to run. This workflow can be triggered when there's a push to the master branch, or it can be triggered manually within GitHub. That's what workflow dispatch means. There are various other triggers you can specify in the workflow file here also. Things like when someone creates a tag or a pull request review, or forks the repo, or creates an issue. Remember, GitHub Actions workflows don't have to just be used for deployments. They can run all sorts of tasks in GitHub that you define by assembling actions or creating your own custom actions. After the section to trigger the workflow, there are two jobs. And each of these jobs runs on separate runner VMs. The first job is called build. It runs on a Windows runner VM, but you could choose other pre-built runners for various Linux distributions. Or you can actually use your own self-hosted virtual machines as runners. Next, under steps, these again are pre-built code components that are available for you to use. Checkout will check out the code from your GitHub repository. Then the runner will get configured using the setup.NET action. The workflow tells the action that we're running this version of .NET. Next, we have a couple of actions that run .NET CLI commands. The first is .NET build with the release configuration parameter, and then the publish command, which specifies a location on the file system of the runner VM using an environment variable. The next action is upload artifact. This uploads the deployment package that was just created to a service in GitHub called GitHub Artifacts, so it can be temporarily stored and downloaded by the next job, which runs on another runner VM. The package is given this name that can be referenced later, and that location in GitHub Artifacts is specific to your repository. It's not accessible to other people. Then the next job in the workflow runs. This job is called deploy. The new runner is also a Windows VM, and this job relies on the build job completing. You can actually have jobs run in parallel, or you can specify here that this job requires another job to be completed. Next is the environment section. Environments in GitHub Actions are used to describe a deployment target, but their purpose is really to allow you to assign rules to certain environments outside of the workflow itself. So you can have certain manual approvals required for certain environments in order for the job to run. I go into that in detail in my course on GitHub Actions. For now, just know that the fact that the name of the environment is dev is what's causing dev to be appended onto the end of the federated identity token that was sent to Azure, the one you saw earlier. We're not going to change anything here though. We'll make the change in Azure shortly. The permissions section is used to define the access rights for this job, which in this case is to allow the job to get an OpenID Connect token used for the OAuth 2.0 authorization to Azure App Service. The steps section starts with an action to download the deployment package from GitHub Artifacts, then log into Azure using the user-assigned identity information that's stored in GitHub Secrets. Then the Web Apps Deploy action pushes the package to this app service into this deployment slot. Okay, now that you understand the GitHub Actions workflow better, let's fix the bug. So we know there was a user-assigned managed identity created to allow GitHub to authenticate to Azure. If we go back to the Azure portal, let's go to the Overview tab of the app service and take a look in the resource group where the app service was created. I'll open that on another tab. There's the app service and app service plan, the deployment slot, another app service I created on the plan for testing, and there's a managed identity here. This is what Azure generated for GitHub to use. Let's open it. There are some values here for client ID and object ID, and if you could see the values of the GitHub secrets that were created, you'd see these values there. But let's look at the federated credentials section. There's a credential here that was created, and it shows the user as token.actions.githubusercontent.com. And the subject identifier is the GitHub account name, the repo name, and environment:production. That looks familiar, except the one we saw in the error message in GitHub had dev on the end, not production. But the issuer is the same. So it's this mismatch that's causing the login to fail from GitHub. We can edit this credential though. Let's change the environment value to dev and update this. Now it matches what GitHub will be sending to Azure. So this is a problem with the automatic setup of the GitHub Actions workflow that was done by AppService. If we run the workflow again, GitHub Actions will be able to log into Azure using the user-assigned managed identity, but the deployment step will fail. And that's because of another configuration issue with the auto-generated setup. And again, this is because we did it from a deployment slot, not from the root production slot. So let's go ahead and fix that, and I'll explain. For this, we need to go to the root of the app service, because we're currently in the development deployment slot. I can't back up the breadcrumb menu here, so I'll just go back to App Services and open up the app service again. We're essentially in the production deployment slot, and you can see the dev slot here under deployment slots. But from the root of the app service, let's go to access control. We need to give read access to the user-assigned managed identity so it can see the root of the app service. I know that sounds strange, but make a note of this in your mind, because when you see weird authorization issues in Azure, when you're accessing a nested item, like a deployment slot for an app service, or a blob storage container in a storage account, it's often because whatever is accessing that child item needs read access to the parent. That's just something I've noticed over the years. So we're going to add a role assignment, and it just needs to be the basic reader role. And next we'll assign it to a managed identity, not a user. And we can find the existing managed identity from this dropdown. And there's the one we were just in. You can actually see the name is visible on the open tab. I'll select this, and let's skip the next tabs and assign this role to the managed identity. Okay, now let's go back to GitHub and to the Actions tab and into the workflow run that failed. From here, we can rerun all the jobs in the workflow, or just certain jobs. I'll rerun the failed jobs, which was the deploy job. I'll zoom out a bit, back to 100%, and let's watch this job run. And I'll speed up the video so we get to the step that failed. And now the login to Azure step succeeded, so the subject claim was found in Azure because we updated it to have dev at the end. And the deploy to Azure web app step succeeded also. If we go back to the Actions tab, it shows that the workflow run succeeded. Now let's go to the app service and back into the deployment slot where the code was deployed to. I'll browse to the deployed app, and there it is. It still shows the code that was deployed in the previous module because I didn't update the home page. But we'll do that in the next clip, and you'll see how continuous integration and continuous deployment have been configured. And at the same time, we'll swap the deployment slots so we can promote this app to production. We've configured continuous integration to the GitHub repo, so let's update the application and see this in action. I'll close this tab, and let's go back to Visual Studio. And let's open up the home page and make a change. I'll save these changes. And let's commit this change to the local repo on this VM. I'll add a comment and commit the changes. Now we can push the changes up to the remote Git repo. Because the GitHub Actions workflow is configured to trigger on a commit to the master branch, that'll kick off the workflow. But Visual Studio is telling me that the remote repository has some changes that we don't have locally. And those changes are just the GitHub Actions workflow file, because AppService created it after we published these local files to the remote repo. So let's pull the change down and then push these changes up to the remote repo. Now we can go back to the browser and to GitHub. And on the Actions tab, there's a new workflow run in process. Let's drill into this. I'll speed this up because it will take a few seconds, but you can see the elapsed time on each job. Once the build and deploy jobs have completed, we can go back to the Azure portal. And I'm still inside the development slot of this app service, so let's browse to the deployed app. And the updated code has been deployed by GitHub Actions. Now let's swap the deployment slots so we can promote this app to production. I'll close this. And let's navigate to the root of the app service. I have to go back to the list of app services and open it again. That brings us back into the production deployment slot, which is the root of the app service. If I go to the Overview tab and browse to the application deployed to this deployment slot, it still has the old home page. So we're going to swap this with the development slot, which will promote the code in development into this production deployment slot. Let's go down to Deployment Center first. And notice that there's no deployment set up here. The deployment is only configured on the development deployment slot. Let's go back to the Deployment Slots tab and click on Swap. The source defaults to the development slot and the target to the production slot, but it really doesn't matter if they're reversed. They're just going to get swapped. Let's click on Swap. This will take a few seconds, so I'll speed this up a bit. And when it's done, let's close this and go to the Overview tab on this production slot and click Browse. Now we have the application that was running in the development slot previously. Let's just confirm that they were in fact swapped by going down to Deployment Slots and navigating into the development slot. And let's browse to the app that's deployed to the development slot. And it's the version of the app that was previously in the production slot. So we've successfully set up continuous integration and continuous deployment with GitHub Actions and Azure App Service.